The visitor pattern separates the algorithms or behaviors from the objects on which they operate. So let's say that you are a developer for a marketing agency that has different types of clients. So they have restaurants, law firms, and retailers. So let's code up a quick solution for this. So here I've generated a client class, and this is going to be like the sort of parent or base class for each of the different types of clients. And you can see here we are storing the name of the client and the contact email of that client. So let's go ahead now and create the law client. So we can create a new C# class, and we're going to call this law client, and this needs to extend the client class. Okay, and then we just need to generate the constructor to satisfy the parent or base client class. And you can see here we just pass the name and the email to this client class. Okay, and we can also create a restaurant client and a retailer client. So let's go ahead and quickly do that. So we have a restaurant client, and we extend the base class, generate the constructor, and we can do the same for retailer. Okay, so we now have some very simple client classes that all extend this base client class, which keeps track of the name and email of the client. So far everything is just a plain and simple C# object. There's nothing interesting going on so far. It's all very, very simple, straightforward stuff. But your manager comes to you and says that they need the ability to send a specialized email with marketing tips for each of the different types of clients. For example, restaurants need tips on how they can better market their food, but law firms don't. So it seems like a good idea to add an abstract method called sendEmail to the base client class, then implement that method in each of the concrete clients. So in the client class, we can create an abstract method called sendEmail. So let's go ahead and add that in. Okay, and we also need to make this class now abstract. Okay, and now you can see we have errors in each of our client classes. So we can implement the abstract class here, and let's just copy and paste this in because it's pretty straightforward stuff. So in our law clients, we are overriding this sendEmail abstract method from client, and we can just log sending law marketing tips, so specialized marketing tips, to the email address of this client. Okay, we can also do the same for restaurant and retail. So again, I'm just going to copy this in to save a little bit of time because it's very, very straightforward. We're just logging a basic sentence just to simulate sending an email, and we need to do the same for our retail client as well. So let's implement the abstract class and paste that in. Okay, so this all looks okay. So we can now send our emails by using polymorphism. So we can see here, I'm just going to paste this into VS Code. So what we can do, if we go into our program.cs file, which is going to be our client, we can create a list of clients. So I just need to import these classes now. Let's see here, what do we have going on here? Let's see. Okay, these should be need to add client onto the end of these class names. Okay, so basically what we're doing here is sort of simulating getting a list of clients from a database. So let's just pretend this is some sort of database query where we get our list of clients from the database, and we have a retail client, a restaurant client, and a law client, and these are all of type client. Okay, so this is a list of clients. Okay, the reason for that is because all of these classes, law, restaurant, and retail, are all extending this base client class. Okay, so back into our program now. So now what we want to do is maybe every week we can schedule to send some sort of marketing email. So what we can do is we can loop through each client, and we can actually use polymorphism to send a specialized email. Okay, so our client here needs no knowledge of the actual specific type of client that we're dealing with, because the send email method is in the base class, which all of these classes are extending. Our clients can just call this send email class and delegate that to the specific client. Okay, so we're using polymorphism here. We don't need to know the exact client. So this appears to be a nice and elegant solution because we're using polymorphism. Everything looks okay. But the manager comes back to us and says that they need a way to export clients as PDFs and as XML. And you quickly realize that your manager is going to keep coming to you and asking you for more and more features for clients. So following our current design, every time that we want to add new functionality, we have to open up our code for modification. So we have to modify our base client class and then actually implement any methods, any specific methods in the client classes. So this is not good because this breaks the open-closed principle, and we risk breaking working tested code. And we're also violating the single responsibility principle, as clients are now responsible for storing client info, sending emails, and exporting clients as PDFs or XML. And also, initially, the clients were just simple, plain old C# objects. They were very simple objects. But adding the ability to send emails means adding third-party library code into these classes that calls email clients like Gmail and Outlook, and this can very easily break our previously working code. So here is the UML for this current solution. We can see that we have our client with name and email fields, and then we are adding a send email method, and we have our concrete or our sort of specific client classes such as retail, restaurant, and law, which implement any abstract methods in the client class. So to solve the issues that we saw previously, we need to extract the behaviors outside of the client classes on which they operate. So if you remember, the visitor pattern separates the algorithms or behaviors from the objects on which they operate. So let's implement the visitor pattern. So here is the UML where we implement the visitor pattern, and we have here an abstract client class, and you can see that we've removed the send email method from this class, and that will now be in the concrete email visitor class. Okay, so the behaviors have been abstracted into the concrete visitor classes, which can then be passed to the objects that they operate on, like so. So here we can see that we are looping through our clients and sending a marketing email. So we can see here we call the client.accept method, and you can see here that all clients must have an accept method which accepts some sort of visitor, and here we have an email visitor which is used to send emails. And then within the specific sort of client classes, so for example in retail, we call visitor.visit retail, and then that deals with sending an email specific for retail clients. Okay, so we can see before that the send email logic was actually on the clients themselves, whereas now we've separated the behavior from the objects which they operate on. So if we have a look at the gang of 4 UML here, we can see it's pretty similar to what we have up here with a small difference. So we can notice that design patterns are not super rigid. So for example, in our case, the element class is an abstract class and not an interface. And this is because we want to provide some common fields and some common methods to all of the clients. So in our case, we have the name and email fields and also the get email method, which is common to all clients. That's why we're using an abstract class and not an interface where we can't sort of store any fields or actually implement any methods. Okay, so let's now implement this visitor pattern in code so that it makes more sense. First of all, I'm going to create a new folder inside of the visitor folder called good, and this is where we're going to put our sort of better solution that follows the visitor pattern. So first of all, let's create our base client method, which will have an accept method that takes a visitor object. So let's go ahead and create that. And this needs to be an abstract class. And here we're going to have the same as before. We're going to have 2 fields, one for storing the name of the client and another for storing the email of the client. And these are going to be set within the constructor of this client class, just the same as before. And we're also going to have a getter for getting the email of the client. Okay, so this is all similar to what we had before, but now rather than having a abstract send email method, we're going to have an abstract method called accept that that accepts a type of visitor. Okay, so let's create that method. So this is going to be a public abstract void method called accept, and this accepts a visitor object. And the visitor object is going to contain the behavior that will operate on a certain type of. It will operate on a specific client object. Okay, so this is hard to understand at the moment, so let's keep on going. It will make more sense as we develop the solution further. So next we're going to create our visitor interface. And in here we're going to create 3 methods, one called visit retail, and this is going to accept a retail client, and we don't actually want to import this from the previous solution, so let's ignore that for now. Okay, so let's just ignore these errors for now. They will go away as we actually create these clients. And we need one for visit law. And we also need a method for visiting a restaurant. And we need to just rename this to law client, and we need to rename this to restaurant client. Okay, so now we need to create the specific client classes. So let's go ahead and do that. So we'll start with the retail class. And this retail class needs to extend the client base class and then implement this abstract method, which is the accept method. Okay, so in here what we're actually going to do is we're going to call visitor dot visit retail. And I think we also need to implement the generate the constructor. That's it. Okay, so I'm not sure what this problem is here. Oh yeah, of course, we have to pass this object to the retail visitor, because the retail visitor is going to operate on this retail client object. Okay, so that is the retail client. And now let's go ahead and create the restaurant client. And this is going to extend client. And we also now again need to implement the abstract methods and also generate the constructor. Okay, so in this accept method, we are simply going to call the correct method on the visitor. And here we are visiting a restaurant client, so we need to call visitor.visit restaurant, and then we pass the restaurant that we want to visit, which is this object. Okay, so next, our final specific client class is the law client. So let's create the law client class. And again, we're going to extend the client class. And we can implement the abstract interface and generate the constructor. And finally, we're going to call visitor.visitLaw and pass this object. Okay, so this is going to now make more sense because we're going to now create our concrete visitor class for sending marketing emails for each specific type of client. So let's create the email visitor class. And this is going to implement the visitor interface. Okay, so in here, this is where we implement the specific methods, and we have the behavior that is now separated from each of these client objects. So what we can do is to send an email for law clients. We can simply log sending law marketing tips email to, and then we can get the email from the law client by calling get email. So this is pretty nice, and if you can remember, so let me just try and tie this together a little bit for you now. So in the law client, whenever we call the accept method, we pass the visitor, which contains the behavior that we want to do. So if we want to send an email, we can say lawClient.accept, pass this email visitor, and then within this method we are calling visitor.visitLaw, and the visitLaw method is implemented inside of email visitor, and it sends a law marketing tips email to the law client's email address. Okay, so hopefully it's starting to make a little bit more sense for you. Okay, so in here we want to send a restaurant marketing tips to email to, and then we want to concatenate the restaurant client's email. And finally, for the visit retail, I'm just going to copy and paste this in to save a little bit of time. Sending retail marketing tips email to retail, and this should be retail client dot get email. Okay, so that is the whole solution. So let's now use this solution inside of our program.cs file. So let's actually use the namespace for our good solution. And we can see, as before, we can create our list of clients here. So we have a retail client, a restaurant client, and a law client. And we have the name of the client, so Debenhams or Frankie and Benny's, Hamlin McGill, for any people that have seen Better Call Saul. And we have our email for each client, our contact email. And what we can do now is we can again loop through each of our clients. And now remember that the send email logic is no longer stored on the client objects themselves. We've separated the behavior, which is send an email in this case, from the objects on which they operate, which are each of the unique specific client objects. So now what we can do is we can say client.accept, and then inside of this accept method we can pass any type of visitor. And in our case we want to pass an email visitor because we want to send an email to each of the clients. So we can pass the email visitor, and if we now run our program, we can see that we are looping through each of the clients and sending them an email. We send an email, retail marketing tips email to Debenhams, a restaurant marketing tips to Frankie and Benny's, and a law marketing tips email to Howard McGill Law Firm. So this is working perfectly. So let's now take a look at why this is such a good solution, why the visitor pattern is a good solution to this problem. So let's say that our manager comes to us asking for new features, and we can now extend our code and we don't have to modify it. Beforehand, if our manager comes to us and asks if we can add some export as PDF logic, then beforehand we would have to modify the client class or each of the individual client classes. We would have to modify our code, breaking the open-close principle. Whereas now, to add a new functionality, such as export as PDF functionality, we can simply extend our code by creating a new type of visitor. So let's go ahead and actually create a new visitor to show you how this works. So if we go inside here and create a new class called PDF export visitor, and this is going to implement the visitor interface. And now here, I'm just going to copy these logs into here to save some time. So here we just say that we are exporting a law client as a PDF, and we can just do the same down here. This is going to be a restaurant client, and this is going to be a retail client. Oops. Okay, so this is our export as PDF visitor class. And then if we want to export a list of clients as a PDF, we can come back into our program class, and let's say we want to send an email, and then maybe we want to export as PDF. So let's now pass this visitor here, PDF export visitor, and I'm just going to comment this out actually so we can see what's going on a little bit easier. And we can see we export retail clients as PDF, then the restaurant client and the law clients. So this is working perfectly. We didn't have to modify any of our existing working code. We just extended our code base by creating a new PDF export visitor, and then we can pass that to each of the clients. So this is perfect because we are now satisfying the single responsibility principle and the open-close principle.